Welcome to Brain Vision.
This question is not difficult to solve, but you have to be quite smart about how can you think about it. So what I'm doing here is the following. We want to determine, for instance, in the first item, the tension in the coupling between the car number 30 and the car number 31. So what happens in this situation is that we have 30 cars pulling 20 cars, and this is the connection that happens between the car number 30 and the car number 31. And then to calculate this tension is quite a straightforward exercise. We just have to apply Newton's second law on either this car set or this car set. I will choose to apply Newton's second law on this car set. By doing that, we get the following. It says that the net force, I'm also applying Newton's second law on this direction, which I'm calling the x direction. So the net force in that direction is equals to the mass times the acceleration of the object. There is only one force acting on that object to the right direction, and that only force is this tension. So the tension force is equals to the mass of that set of 20 cars, so 20 times the mass of each car times the acceleration of that set of cars. Using the information that we're given in the problem, we get a tension that is equals to 20 times 6.8 times 10 to the third times 8 times 10 to the minus 2. And this is 20 times 8 times 6.8 times 10. So the tension is approximately 1.1 times 10 to the fourth newtons in this situation. On the other situation, we have only one car that is pushed by 49 cars. Applying Newton's second law to that single car, we get the following. Net force is equals to the mass of that single car times its acceleration. The net force is the tension force. And then this is equals to 6.8 times 10 to the third times 8 times 10 to the minus 2. This is 6.8 times 8 times 10, and this results in a tension of approximately 5.4 times 10 to the second newtons.